Okay, so this is 7.7 retrieval, number one. And it says find the two angles from 0 to 2 pi that are solutions to the equation and then round your answers to the two decimals. So clearly they're telling you you're going to be using a calculator whenever they tell you to round. So the very first thing that I do is I ask myself, dude, theta is stuck in cosine. How do I get him out? And normally I would draw an angle. I would draw like this kind of guy, and then I would graph him. He's negative cosine. So negative, so that would be, sorry, adjacent over hypotenuse. I would normally do this, right? And so I'm like, oh, he goes that way, kind of like that, because it's negative. And I'd be like, wait a second, there's two angles because cosine is also negative down here. So I'm looking for these two angles, right? But these numbers are unrecognizable to me, as in it's not my 30, 60, 90 triangle with 1, 2, root 3. And it's not my 44, 45, 90 triangle, which is 1, 1, root 2. So these numbers are unrecognizable to me. So I'm like, ugh, this is not it. So that means I'm going to have to run to my calculator. And so the way I'll do this is I say, how do I get theta out of cosine? So how do I get theta out of cosine? Yeah, cosine inverse. Perfect. So what we're going to do is we're going to take the cosine inverse of both sides. And I'm going to write this out properly because I want to make sure everybody knows what I'm writing. So the very first thing I'm going to do is I'm going to copy this equation, cosine theta equals to, and then you notice me scooting over negative 9 over 41. And I like to put the negative on top because I don't like him to get lost, right? And then you told me that I need to take cosine inverse of both sides. Cosine inverse goes like this. He needs something next to him, as in to the right of him, to take the cosine inverse of. Okay. So then if you notice cosine inverse cosine, they inverse each other. So the only thing I'm left with on the left side is theta, which is equal to cosine inverse of 9 over 41. And that's what I'm going to bring in my calculator, right? So over here on my calculator, I'm going to go cosine inverse of negative 9 over 41. And I'm going to look to make sure that that is what my work looks like. And this is why I love Desmos so much, is because the way I'm expecting it to look and it looks like on my paper, that's the way it's going to look. Now, if you're using another graphing calculator, like one of those handheld ones, it doesn't actually look like this, which is not my favorite. So your brain had to get used to looking at something that on the graphing calculator there versus your paper. But here they look exactly the same. This is why I love Desmos. Okay, so the answer they said is 1.792. They said they wanted my answer to be in radians. I need to make sure that this guy is in radians. It is. So I get 1.792. 1.792. Now, going back to my original drawing, I had said, oh no, there's actually two answers that, oh, to two decimal places. Shoot, it's just 1.79, guys. I just read this part, two decimals. So now I need to look for this guy, right? I need to look for this guy. So the way I can't just do things. So 1.79 is actually, oops, sorry. So 1.79 is this guy. And I actually need the reference angle in there, the rest to pi. I need to find this guy right here, this angle here. Because if I know that angle, then I can figure out this, the bigger angle. So the way I do that is, again, I bring out my Desmos and I go 3.14 minus 1.79. Oops, no. And I get 1.35. So this guy in here is 1.35. That means this guy right here is 1.35. Please do not think that 1.35 is your answer. Because if you know 1.35 is somewhere over here, and that's not the answer we want, right? That's not it. So I'm going to erase that because that's not what we want. Okay. So then, Miss Johnson, how do I find that angle? Well, if I start from here and I go all the way around here, what's the math on that? What is the math on that? Yeah, very good. Very good. There's a couple different ways to do it. Someone said ah, we could do 1.79 plus 1.35 plus 1.35 exactly, right? Another way you could do it is go 3.14 plus 1.35. Get the same answer. Which way do you like better? Great, do that way. Whichever way you saw better makes sense to you. So that's the way that you should do. My job is to show you different ways so that your learning would grow. So then my other answer would be 4.49. So let's go over this really quickly. The very first thing I did was I was like, oh, I need to draw my picture. So I drew my picture. And if you don't know how to draw this picture yet, the biggest thing that you have to ask yourself is, this is a famous question, where else is cosine negative? Okay. And cosine's negative on the left side because cosine represents x. So everything on the left side is going to be negative. So those are my two angles. And because those are my two angles, then those are my two angles. And then that helps me find that. So then moving over to the equation, I said, okay, well, darn, theta is stuck in cosine. How do I get him out? And you guys said, oh, use his inverse. So cosine inverse both sides. The cosine inverse of cosine theta is just theta. You're doing the undoing, right? I opened the door, you closed the door. Now it's set back to normal, right? Okay. And then I cosine inverse the other side, which then I used the calculator, made sure that it was in radians, and then it outputted my answer as 1.79. But they told me to find two angles. Calculator only gives me one answer because the calculator is a function, meaning you ask it one question, it's going to give you one answer back. So now I have to find the other answer, which is why we went back to our drawing. Okay, so be comfortable in those drawings and you should be fine. And both of you calculated that perfectly, so I'm not worried at all about that. So thank you for listening. Have a great day.